All right, welcome back. And right now I'm going to go through and how to simplify expressions. Um, I always go through this every year because I think it's really important that students know how to use inverse operations when dealing with logs and exponentials. And give you an example, um, just so you know, when you have a logarithm, an exponential, so let's say I have y equals a to the x power, all right, and I have another one, and I'll say this is equal to f. And we have another function, which we'll say is the inverse of this, which would be log base a of x. An inverse property would be if you compose a function with its inverse, that should always equal x. And so what that means is that if these are inverses of each other, which they are, okay, so this property only works if they're inverses. All right, this is one of the major big time properties that you should always know. All right, math students out there. All right, is that a function composed of an inverse equals to the value inside, all right, which is in this case x. So if I would take a, all right, f composed or g composed of f, that would be a to log base a of x. And we normally think about, okay, these cancel out. Well, they do in that they are inverses, and therefore this would equal x. In the same way, if I would go and say g composed of its inverse f of x, that would have to equal x as well. Therefore, if we had log base a of a to the x, once again, using the inverse operations, these cancel out, and this equals x. So what I want to do is I want to show you some different problems where we're using this inverse property to solve and simplify different expressions. Actually, just simplify expressions. One example would be if I had log, so example number one, log base 8, and I would have 8 to the 7x squared. All right, well, once again, I have a log base 8 of 8 to the 7x squared. Well, this is an inverse expression, so what would the answer be? Well, since these are inverse of each other, it would equal the value inside the exponent, so our answer would have to be 7 times x squared. It's just the exponent, because these cancel out. All right, hopefully that makes sense. Let's try another one using this inverse property. We'll actually do quite a few. All right, let's say I have this. All right, this is a little bit tougher one. Let's say I have e4 plus the natural log of, oops, let's put something else in there. Let's make it a little bit more difficult. All right, plus 3 natural log of x. Now, here we have to do a little bit more work in order to find out an answer. If I have e to the fourth plus 3 natural log of x, and I want to simplify this, I can't just cancel out. I see a natural log and whatnot. I can't just cancel that out. What I have to do is I have to make it so I have just the property where it's just e, the base, is to the natural log power. So it's like that. In order to do this, I have to use the properties of exponents and simplify this. I can write this as e to the fourth. Because we're adding exponents, it's the same thing as multiplying e to the 3 natural log of x. Now, once again, I'm so close. I wish I could just cancel this out. Many students do and just put 3x as their answer, but that's not true. It can't be. You only can cancel out if it's just a log base a of x. But we have this 3. How do we get rid of that 3? Well, using the properties of logs, we know we can take that 3 and put it as the exponent of x. So I'm going to write this one more time. E to the fourth times e natural log of x cubed. From there, what we know, we can now use the inverse property. We have e natural log, this canceled out, and we're left with, well, let's put our answer up here. E to the fourth times, well, what's left over? X cubed, and that's our simplified answer. Makes sense? Usually that one confuses a lot of students. So let's try a couple more. All right. Some easier ones, some harder ones. Let's say I have, let's try this one. Oh, here we go. 8 log base, let's put another 3 there. All right, 8 of 2. All right, 8 of 2. Now, once again, normally we would just cancel these out, but we have this 3 just sitting there. So how do you get an equivalent expression? Well, we have 8 and 8. It would be cool if we get rid of this 3 because then we can cancel out. We can by once again using the properties of logs, and that can go as the exponent. So we can rewrite this as 8 log base 8 of 2 to the third. What happens now, these will cancel out, and we're left with then is 2 to the third, which we can write as 8 as our answer. That's starting to make sense? All right, let's just try two more. All right, some other properties of logs. Okay, let's see if we got this one. What do we have? Yeah, an easier one. I'm looking at my notes, trying to think of some different ones. All right, if I had log of 10 to the 3x squared minus 4x plus 1, what would that be? Well, hopefully you realize that log, this is a common log. Common logs have a base of 10. So 10, there is nothing in front, so yes. Using the inverse properties, log and 10, these can cancel out, and we're left with 3x squared minus 4x plus 1. That's our simplified answer. That's it. Okay. Final one. All right, this always throws students for a loop. If I said find log base b of negative 5, that's a b, negative 5. Now, this isn't really using any of the inverse properties, but it's just using a property of logs. But what is the answer? Well, hopefully everybody knows that um, this answer does not exist. You cannot take the log of a negative number ever, okay? You can have a log base b of negative x, because that's a variable, but you can have a log of a value, all right, of a value. So that one doesn't exist. And the reason why, if you're wondering, because remember, logs are exponents. We're always saying to ourselves, what is the exponent of b that will give me negative 5? That's how you solve that. What is the exponent of b that gives me negative 5? Well, there is no exponent of b that will give me negative 5 because you never get a negative number. So that is why that one doesn't exist. All right. Well, I had to share that one with you because that's one that I know a lot of students always struggle with. But using inverse properties, using the properties of logs is really important. So I hope this helps you out in solving and in simplifying expressions. All right, good luck and God bless in the rest of your problems.